Hello everyone, this is Sujay and today I'll be presenting my project titled Air Parameters Monitoring with Data Logging. The goal of this project is to design and implement a system that can monitor important environmental parameters, specifically temperature, humidity and air quality, and log this data for later analysis. Here is a photo of the setup I've built. As you can see, this setup includes an Arduino Uno R3, various sensors which are mounted on the breadboard, and this dust sensor as well. The 2x16 LCD screen is used for real-time display of values, while the SD card module logs data for long-term storage. Everything is connected using jumper wires on the breadboard, powered either through USB or a battery pack. This hardware configuration makes the system much more modular and quite easy to expand as well. Let's walk through the hardware components in a bit more detail. I have used the Arduino Uno R3, which is based on the Atmega 328P and quite simple, reliable and beginner friendly as well. The next five are the sensors. Coming to the DHT22, this is used for measuring the temperature and humidity. The BMP180, which is used for measuring barometric pressure and temperature as well. The next two sensors, which are the part of the MQ sensor family, are mainly used for detection of gases. The MQ5 sensor is used for LPG, methane and some other types of gases detection. The 131 is solely used for ozone detection. The GY2010, also known as PM2.5, is a dust or particulate sensor. The keypad is mainly used for the input for date and time and then log data every 1 minute into the CSV file. And a micro SD card module where we put the micro SD card and it acts as an adapter with the Arduino Uno. Power is supplied via USB or batteries depending on portability. Here I connected this with the laptop via USB, which would give it a stable power supply of 5V and enough current to all the components. All the components are mounted on a breadboard for prototyping. Now let's look at the data logging part. This screenshot shows the CSV file generated by the system. I've opened it in Microsoft Excel. Each line represents a data entry with parameters like date, time, temperature, humidity, and air quality index. Using the Arduino SD library, I formatted the output in CSV format, which is quite easy to read and process using Excel or Python. We can also graph this data over time to visualize trends such as how temperature and humidity vary during the day, or how air quality responds to indoor activities like cooking or cleaning. This makes the system very useful for long-term environmental monitoring and research as well. Now coming to the challenges, there were quite a few challenges while building this because a lot of sensors and modules are being put together at the same time. One major issue was with the power supply. While the setup works fine when powered through a USB, using a typical 9V battery was not sufficient to power all the components reliably, especially the SD card module and LCD. The current drawn would sometimes cause the microcontroller to reset or freeze during data logging, or the LCD would keep on blinking without showing any characters which it was supposed to show. A better option would be to use a regulated 5V power bank or a lithium-ion battery. Another point worth mentioning is on the use of analog and digital pins. The air quality sensor MQ5 and the ozone one as well were connected to analog inputs since they output variable voltage based on the gas concentrations. On the other hand, the DHT2 sensor uses a digital pin with a specific communication protocol. Efficient use of input output pins and careful pin assignments were quite crucial for stable operations, or else there would be problems in data logging or the LCD would show some garbage characters. And for the further improvements, I would like to add Wi-Fi or Bluetooth functionality. Uh, this can be done by combining Arduino Uno with ESP8266 module, which has Wi-Fi compatibility, or by simply using ESP32 board, which is Wi-Fi compatible as well. This would allow real-time wireless data upload to the cloud using platforms like ThinkSpeak or Blink. Users could monitor their environment from anywhere. And lastly, the idea is to develop a mobile app that fetches and visualizes data instantly. Thank you.